What is happening today with DNS and why we actually should look into the security of this infrastructure?
HTTPS brings a lot of overheads.
Why do people misconfigure? What's the hack?
So basically there is no security, there's no encryption, there is no signatures.
Is it an attack? And where are these private keys? Hi everyone, very happy to welcome you back to our sessions where we talk about networks, security and general applications for IoT. And here is Alexandra and
Ivan
from Staex. So we were talking last time about IoT projects, and one of the biggest topics also today on the internet is the networks for these IoT projects. And today we've chosen a topic of DNS. So today we will discuss a little bit what is DNS, how it's used today, and why this is still an issue, can be an issue within the security of the broader context of networks that are being used today. We should look into this topic, and actually this is crucial for IoT applications. So DNS is a domain name system, a protocol that we enjoy up until today, has been developed many years ago. It's actually the core of our infrastructure. Everything that all of us are accessing the services is basically built on this. So Ivan, I think that a lot of modern application providers are not really coming from the network topics, and however, this is still an issue. Maybe you can describe a little bit what is happening today with DNS and why we actually should look into the security of this infrastructure.
Sure. First of all, DNS is a very old protocol. It's like 30 plus years old.
Wow.
And most of the problems came with the legacy of this protocol and with the fact that everything in the internet, and not even the internet, but in any IP-based network uses DNS. And like every device, every server, every computer, they all use DNS, and we can't do anything with the protocol because we will have the backward compatibility problems, and which we will not solve. For example, for like devices that have firmware that cannot be updated, etc., etc. So it's a huge endeavor to actually change the DNS, and most of the problems came from the fact that it's legacy.
Okay, well, can you please explain a little bit why still up until today even IoT have to use it? Because just also for the audience, DNS is something that takes the human readable names and translates it into IP. So I would just assume that for some IoT applications it shouldn't be a requirement to use DNS because I guess machines can deal with the numbers as opposed to us humans. But somehow it's being in use today. So maybe you can cover this a little bit just to understand more why is it still happening.
Of course, it's right that you're correct when you say that machines probably don't need this. However, the technologies evolved in such a way that we can't remove DNS from the machines completely. I can give you one example. The most the most popular encryption protocol is HTTPS, at least on the internet, and we have a lot of websites that use HTTPS. We have a lot of API servers that use HTTPS for encryption, and this is actually a good thing because HTTPS is well researched, it's audited, it is based on the well spread libraries, and it is much better to use the ready-made solution for security instead of rolling out your own. And this is a great achievement for HTTPS. However, since people not only use HTTPS for websites, but also for servers that ingest the data from the devices, or maybe control the devices remotely. The devices also have to use HTTPS, so they have to make the secure connection to the API server to send the data, to receive the commands, and to basically function as they are intended. So you need to also you need to use HTTPS, and the hook to the DNS here is that certificates for the HTTPS servers are linked not only to IP address but also to DNS name.
All right. But just to summarize, what you describe right now does sound a little bit for me that devices are also treated as normal computers. So there is no differentiation from this perspective. Like there is no any dedicated specific infrastructure for IoTs, and I don't know, from my perspective it also looks like a huge overhead for a lot of IoT applications where it shouldn't be happening.
For sure, HTTPS brings a lot of overhead. We have our own story also with this protocol, and basically if you want to have a HTTPS client running on the device, maybe on the router, maybe on your smart light switch, or just a smart light bulb, whatever you prefer, you have to bring a lot of dependencies. So you have to allocate a lot of disk space for the actual code that implements this standard. Right now there is no good alternative. Of course, you can use mutual TLS, which is another standard which also uses the same security. You can find libraries that are much smaller than the HTTPS libraries, but with this standard you do not use web, and you need to create your own servers that use your own protocol. It will be non-standard protocol, whereas HTTPS is quite standard protocol, and you can use JSON or maybe even binary data with this protocol. And yeah, we have alternatives, but most of the devices don't use them, and they are not widespread.
I understand. I mean, also the prominence of the HTTPS protocol, as you said, it's the amount of libraries that are supported, and that's why that's I guess a go-to solution right now. However, I think it's interesting. We were preparing for this conversation, and we've seen that still a lot of attacks and outages today on the internet happens because of DNS somehow. And even I would say famous misconfiguration of BGPs and DNS happened throughout the years. I think the last one we've seen, it was 2021 with Facebook. So it's quite impressive that this misconfiguration happens. Why do people misconfigure? What's the hack?
Well, you should ask Facebook for like the correct answer. But usually, the problem with DNS misconfiguration is that many enterprises still use DNS internally for their internal network configuration, simply because they are humans. It's easy for them to remember names and understand what this name means in the context of the configuration, instead of for example, using IP addresses, which has no meaning for human. And the reason why many such misconfiguration occur is that you have recursive dependency on this DNS name. So you have a part of the configuration that configures the DNS server, but other parts of the configuration rely on the DNS server be available and to resolve the name into the correct IP address. And if your DNS fails, then other parts of the configuration fail, and there is no easy way to untangle all these dependencies. So basically, you like DevOps, they usually deploy for the first time the system. That they deploy the system like in waves. So they configure part of the system, part of the configuration fails, then they configure it once more because the another part didn't fail,
right.
and you now have the working DNS server, and then another part of the configuration actually succeeds. So it's kind of it's the same problem as with the compilers, and it's basically recursive dependency
right.
on the configuration on itself.
Sounds like a fun job, though. So coming from the misconfiguration, let us talk a little bit, go a little bit back and just talk about the DNS in general. What's about security? How did they see security 30 years ago? Like, what does DNS offer with regard to security? And, you know, we're using it today for critical applications, etc. So let's talk, how is DNS with security?
Well, if we are talking about the original protocol,
right.
conceived like many years ago, then there is no security at all. So it's UDP based.
Yeah.
You have a packet up to 512 bytes that is sent to the DNS server, which contains the request for name resolution. So it contains the name, but it doesn't contain the address. And the server replies with the same, basically the same packet, which contains the initial request, but also contains the one or maybe not one, but 0 or like n
right.
replies, mainly IP addresses or DNS records. DNS records can be also different types, but usually it's IP addresses. And then you receive this reply, and you can do something with this. So basically there is no security built in, there is no encryption, there is no signatures, so you can't verify that the data hasn't been altered in the process. And this is how most of the servers and
that sounds like a good start.
For sure,
yeah,
for sure.
Yeah,
but one advantage of original DNS is that it's really simple. It's really simple, and over the years people created a lot of different record types, and basically with these record types DNS evolved into something more secure than it was originally. And
is there any specific DNS secure protocols that have emerged that are being used right now, or is it more kind of industrial best practices that are being used today? Or is it a combination?
Yeah, unfortunately it's a combination. So basically we have DNSSEC extensions. These are a set of security extensions to the original protocol, and the standard that describes them is quite extensive. And we have basically they add the signature to each DNS record. And in order to implement this signature, you have to implement it on the server first,
right.
and then on the client, and then on every intermediate server through which you receive the result for your query. And unfortunately, clients right now are configured in a way that if the entry doesn't have a key, that doesn't have a signature, then it's simply ignored. So this fact is ignored. So you will get the result IP address, and there will be no error because there is no signature, because they want backward compatibility, of course.
Right.
And this is kind of...
This is a problem.
Yeah, this is also a problem. But otherwise, if you have signatures, and most big sites and most companies that know how to use DNSSEC, they have these signatures, and you can verify them at least.
Understand.
And then when the verification fails, of course, you will not get any result.
It sounds a little bit even more overhead for if we talk about IoT applications where DNS shouldn't be maybe even used, and then you add signatures where the devices have to compute signatures. Like it sounds, like the waterfall goes on, and this kind of looks like a very inefficient setup from certain angle of IoT, how it's working today.
For sure, I'm sure that if you have a small IoT device, let's say, embedded device, then for sure you can't use the secure DNS because it will consume a lot of space on your device, a lot of memory. And the solution that we have right now is to use IoT gateways. IoT gateways are like routers to which you attach all your IoT devices, and then on this router, since this is quite bigger device, you can run there the DNS resolver that supports DNS security, and basically you route all the traffic through this resolver to validate all the addresses. Okay, interesting. So I mean, happy there are some solutions, and we still, just to summarize, DNS is still being used for IoT applications, and it's an integral part of the setup today. And just as you said, there are security extensions which are not enforced, so there is no way of enforcing them on the network. And tell us a little bit more about how attackers actually attack DNS today. So about, for instance, how do they do cache poisoning today? So what is actually happening with regard to these attacks on the internet? There are quite a few attacks on DNS, of course, because this protocol is not well protected and not protected by default. So this is a big attack vector for hackers. There are several attacks. So basically, we have a DNS spoofing attack. Spoofing here means that some malicious server joins the network, and this server replaces some records, DNS records, with other records, which point to an attacker website. And if your device tries to resolve this record, then all the data will go to attacker's website. Basically, DNSSEC solves this problem. Not to the full extent, unfortunately, because the protocol is still not encrypted. So you can also spoof the address with man-in-the-middle attack. But still, the DNSSEC is one component of this solution. Another attack is man-in-the-middle attack, and this is the same. This attack it has the same goal. So the attacker wants to replace a valid DNS record with another record which points to his website, and then all the data goes to this website. This attack is possible because there is no encryption, and you can run a DNS server with the DNSSEC configured, and then it will be valid DNS server, so it will pass all the checks, but still the address will be spoofed by an intermediate node. Right. And to protect from this attack, we have two protocols right now. It's DNS over HTTPS and DNS over TLS. There is little difference between them. Basically, they use the same cryptographic algorithms for encryption, and probably the same libraries in most cases. And you can use whatever you prefer. And the idea of this protocol is to wrap the original DNS packet into either TLS frame or HTTPS frame. And with this wrapping, with this frame, you get all the security benefits that were developed over 30 plus years for the internet and that are used today. Right. I mean, again, just to put it also into the IT context, it sounds like a great solution if we talk about financial applications, where humans are involved, banking, etc. Still adds a lot of overhead for IoT communication, and I guess that for some of the IoT apps where the costs are actually important of the whole overhead and data traffic that is happening massively, this can be of course of issue for the future, right? Well, I am sure that all the banks they use some kind of this protocol. Maybe not all I think like the banks and financial organizations, they are far ahead in this world, and they've been doing this for ages. Probably they have their own protocols that maybe they will replace it with TLS and HTTPS to not support them, to not spend time on this. But mostly, I think they are all mostly secure. If we talk about IT devices, like card readers, etc., I'm sure they also use like some proprietary protocol. So I think we are good here.
Right.
However, if you talk about like smart meters, maybe other smart devices, it's up to vendor of IoT gateway to configure the encrypted DNS to make everything work.
Right. Okay. And what is also coming back to the DNS structure itself? Like, who controls it today?
Today, DNS system is hierarchical, so it's centralized. We have several root servers that has their own private keys that protect the data. They of course all use DNS security extensions. I'm not sure if they support DNS over TLS or DNS over HTTPS. Probably they should support it. And if you imagine like the calamity scenario, when one of the private keys is lost, then of course it will affect the system. But since we have like several DNS servers, then several root DNS servers, then probably this is this is not the end of the world. So it's a big issue, but
all right. And where are these private keys?
I think they're stored offline as any private key that is really valuable.
Okay.
I hope it is stored offline. But otherwise, I'm not familiar with the whole procedure.
Right. Well, is it true? Like we discussed, I did meet at one of the conferences a person that told me that there are like 12 organizations of people, just like real people, that have these keys, and they come together once a year to put the keys together. Like, is this this is true, right?
Actually, I don't know. I read about this on the internet. Probably saw a few videos about this. They host a ceremony of taking the keys out of the safe boxes,
right,
with the physical keys, and
right.
I mean it looks like it's a ceremony. No one. I'm not familiar. I don't know these people, so.
Yeah.
Well, I assume so. Well, at least these keys are stored offline, so this is a good thing, and I hope it will not be hacked, or maybe someone could be bribed to retrieve the key. But I don't know. I think it's mostly conspiracy theories.
Okay.
And for sure, the key that is stored offline, it's really difficult to retrieve.
Right. So it's just to summarize. So the DNS is a problem throughout the topics that we discussed. It's an older protocol, so it is. Basically, it has advantages because it's a proven technology, and this is a simple protocol. However, because of the missing security, and of course a lot of misconfiguration happens. And I just think also I had a feeling working throughout the different companies. Also, the newer the generation is of developers, the less they actually were in touch with this side of the internet. I'm sure that all of our infrastructure depends on this 10 keys that are stored offline. Maybe this is the knowledge that is not really taught in the schools today, and so the developers are also getting kind of further away from this, and that's why a lot of misconfiguration happens, and it's just what I felt also this different profiles, like the application developers. There are less and less people that actually understand networking, and it also became a very narrow skill set from that perspective. And I just also application developers don't want to be bothered with this complexity. It just should run in that sense. So this is really interesting. We discussed who owns the DNS and how the structure is built, and because it's a hierarchical structure, there are also organizations that make money with DNS. Like for instance, very prominent DNS server is Google DNS server. How much this is used, and maybe you can name an example of IoT or maybe automotive use cases that are using this DNS, and like how much choice do we actually have when we install DNS routing in certain cases? Maybe you can cover this.
Sure. I don't know how much Google can get money from hosting a DNS server, but probably they can analyze the traffic and basically what they do with their search, so that they know more about the internet, and when they know what addresses people resolve. The problem with Google DNS is that many system administrators and many developers, many people in general, they use it by default. So it's like 4.8 octets, and they use it by default. And the recent DNS that also appeared on the horizon is Cloudflare DNS. It's 111 IP address. Many people also use it by default. We can't blame them. However, because this DNS servers, they also support like the old protocol, the new encrypted protocols. They support DNSSEC, of course, so that they are up to date. However, some people encode these addresses into their firmware. And this firmware is used, for example, for cars, maybe for some other IoT devices, and basically you can't change it. And as I said, by default, the system right now uses the old protocol, unless you configure it otherwise. And most of these systems, of course, use default protocol because people are not aware, or maybe some developers are not even aware about all these problems that they need to solve by their own, because the default is the old protocol. And one way to fix that is the usual way is that the router to which you connect your device need to perform a man-in-the-middle attack and replace this DNS server with the resolver that actually encrypts the traffic and actually uses DNSSEC, etc., etc.
Oh, wow.
So the traffic between your device and the router will not be encrypted, but the traffic that goes out of your router will be encrypted, will be safe to you can rely on this traffic, of course. And this is a solution that we have now.
Sounds a little bit more complicated if it's a dynamic setup, no? I mean, if you have kind of a fleet of cars.
Maybe. Yeah. This setup is complicated if you don't have a router.
Yeah.
But with the router, it's quite straightforward to configure this, and of course, thanks to the legacy protocol, with which we can do anything, probably without client noticing, then we can also make it secure without client noticing.
Right, okay. That's pretty interesting to learn about this setting, that it's hard-coded and nobody can actually change the settings, only with some workarounds. So this is also, I would say, another challenge for IoT developers to actually mitigate it, and especially if you talk about at scale, right? If you have 2 million devices, this becomes more complicated at scale, all the networking issues.
For sure, I think this problem Well, I consider this problem actually like the second order. So because most of the companies they can use, for example, VPNs to route all the traffic, and in this case it's actually encrypted by a VPN. However, private individuals, for example, they park their Tesla car, and this Tesla car uses instead of their DNS and on the router, it uses Google DNS and uses it without encryption. So they need to solve this problem by their own, and most of the people, they are not actually aware of this, and there is no like simple web UI switch to enable this. It's not. It is something that system administrator can do, but regular people, they don't know about this, and they don't have a button.
And they probably don't want to, dealing with this. We in our complicated lives have enough to deal with, and
for sure.
But it's still not nice to know that companies know where you park. I would also start to slowly wrap up and talk about the very interesting topic of the data exfiltration. Is it an attack?
DNS data exfiltration is a technique that attackers use to copy the stolen data to their servers. So it's not an attack on its own, but it's a component of the attack. And I also consider this a second-order problem, at least for the IoT devices. However, because you need to hack the device some other way to actually exfiltrate the data. However, this attack is really, like this DNS exfiltration is really a big problem on both sides, both on the client and on the server. And well, if you consider a server side, let's say Cloudflare DNS, how can they protect from this attack? So first of all, this attack works like this. You have an attacker creates a server, DNS server, that is linked to an attacker's domain, a domain that they own, and the infected host resolves the subdomains of this domain, and if this subdomain, the names of these subdomains, they're like machine names, so they encode the data that was stolen. So these are not real domains. These are domains that do not exist, and they encode this data. However, when you try to resolve them, even if you do it with encryption, with DNS security, etc., so if you implement all of the techniques that we're talking about, even in this case, an attacker can get your data through all these secure DNS servers up to his or her server. And this happens because these are simply domain names, and people can't filter them. So there is no blacklist of these names. So how this problem can be solved on the server? Probably there are some techniques, I don't know, it's the same. Probably this is the same techniques that antiviruses use, because they have the signatures of they have signatures of viruses, but on the server you can have signatures of programs signatures of packets, DNS packets that are sent by certain programs, because some programs that they send DNS packets with specific flags for one reason or another, and you can detect this. But on the client side, it's quite simple to actually mitigate this attack. You need to have a whitelist of servers that a whitelist of DNS names that you allow to resolve to IP addresses, and you of course will have this dynamic list of IP addresses that also can be used by your applications. So you limit all your outbound traffic only to these IP addresses, and you only allow to resolve these DNS names from certain DNS servers.
Right. So
And
like
since
filtering.
it's exactly it's filtering, it's client side, and well, sometimes it sounds scary because you use a lot of some deployments of IoT projects. They use a lot of different DNS names. One DNS name for containers, one DNS name for packages, another DNS name for their own server, etc., etc. But this is the ultimate solution to this problem. However, we also have these encrypted protocols right now, and if an attacker tries to exfiltrate the data using DNS over HTTPS or DNS over TLS, then it's quite complicated to actually solve this problem. And basically you need to the only way that I know is that you need to intercept this traffic, and since this traffic is encrypted, you have to basically perform a man-in-the-middle attack again using HTTPS server that you own, and you have to trust, of course, your own certificates to do this. This is quite difficult to implement, and
also expensive, right? If you implement it, that's kind of very expensive.
Yeah, probably this can be expensive, but it's really difficult to implement. There are no ready-made solutions, and actually re-encrypting the traffic and using man-in-the-middle attacks, it's kind of this is what people don't want to do with their networks, that they feel like something is wrong with their network. It's probably not the best solution, and I think in the future, I hope in the future we will have something better.
Right. Okay, so let's then start to wrap up a little bit, and also we started to talk about DNS, and our angle from the series that we're doing is still IoT and how IoT should be built in the future. So after everything we learned and how the infrastructure is has these issues in some from some perspective, and so the provocative question will be do we actually what will be the way forward? I know it's hard to answer because we can talk for the whole industry and it's hard to change certain things, but listening to all of this and coming back to the question that I asked, is DNS actually needed for IoT, and how can we envision the future maybe from this perspective in 10 years? Do we actually need it, and can we come up with something that is more lightweight, more secure, and can help us to manage this machine economy in that way in the future?
For sure, there are two approaches here. First of all, we have legacy devices that we can't change, so they use legacy protocols, and we can't change it. So the solution for them is really simple. You attach them to an IoT gateway that basically intercepts all the traffic, encrypts it, and sends back the responses. And the second approach is for the newer devices that can actually run a VPN, or they can actually be configured to use a secure DNS. The approach here is to actually configure this security extensions and configure encryption for these devices, or use a VPN.
Now we are in the first topic that we covered last week, with the VPN.
Yeah. So
right.
The VPN is it's the cornerstone for your IoT solution, because everything becomes simpler with a VPN. Even if you haven't configured the encryption for the DNS, the VPN will do it for you. And you can, for example, you can configure the encryption on the server that ingests the data from the devices, and on all other devices you could simply forward the traffic to the server and let it resolve every name. It also helps with not only DNS traffic, but with any type of traffic that devices produce, because even if you use all the encryption methods, all the encryption methods, but you access third-party server. We talked about this last time. It's like OCPP servers used by EV chargers. This is a best example of this kind of problem. And if you use this third-party server, they still see your IP addresses. And if you forward the traffic through the server, they will see an IP address of some data center, and they will not be able to track your devices.
Right. Understand. So, I mean, it looks very positive that there is a solution, so that the IoT creators can use VPN today. We covered some of the issues with VPN for IoT in the last episode. And this will be probably also highly advised, because now that we learned about the complexity with DNS and the misconfiguration that can happen, and I guess also if you're in a bigger team, you have to implement processes, to mitigate this possible misconfigurations. Then it becomes even more complicated. So happy that we learned about all the DNS and security issues, and there is a viable solution for IoT creators. Maybe some last words from your side?
Well, what can we say about DNS? This topic not only for IoT devices but also for like laptops and
all of us.
for the servers. This fascinates me, how long it took to make all the security extensions, to make encryption, and still it doesn't work. It isn't secured by default, unfortunately. So this is the only solution that is. I mean, if you try to secure the DNS if you list the steps that you need to perform on each operating system, they will be different. There is no ultimate solution, and also there is no such option on most routers. You need to configure again by yourself all this traffic redirection, all this encryption, etc. So unfortunately, we came to conclusion that DNS is not safe by default, and the only way, the easiest way to make it safe is to actually use a VPN, either on your devices or IoT gateway or even on your laptop.
A lot of VPNs don't really address IoT specific features, and the complexity with DNS and being not secure by default probably leads to what we see a lot in the industry, that there are some amount of applications where you just see a lot of unencrypted traffic. A lot of people think everything is encrypted, but actually with regard to IoT, that's what we see happening, that actually a lot of just clear traffic present on the internet, and this of course would be great to change in the future.
For sure.
Right. Okay, thank you for listening. As usual, we will be happy for you to submit any topics that we can discuss here about networking, IoT, and security. And also, please share your opinion. What do you experience? How do you like DNS? And we'll be happy to hear any of your comments. Thank you so much, and see you next time.
See you. Goodbye.